All right, section 4A, video number 2, we're just going to introduce the idea of an exponential function. All right, and we'll do this by way of an example. Let's say that you get a job and your starting salary is $40,000. And this company has a policy that if an employee is doing well, then they get a base increase, a pay raise at the end of the year of 3%. All right, so we might go at the end of your first year and we would calculate your $40,000 plus we would tack on 3%. We would do 0.03 times $40,000. And that would give you $40,000 plus $1,200, so $41,200 for your salary after the first year. All right, so I'm going to show you a different way to calculate this because we're going to do this a few times and it's going to get a little tedious if we don't get a shortcut. That has two terms and they both have a 40,000, so we could factor out a 40,000. Right, which would leave me in the first term with a 1 and a 0.03 in the second term. Or 1 plus 0.03 would be 40,000 times 1.03. And you can check in your calculator that that gives you the same ending salary. Okay, so it's a little faster when you want to increase something by 3%, just to multiply it by 1.03. All right, so then at the end of our second year, you don't just get another $1,200. We would take your $41,200 and we would increase it by 3%. And I'm going to let my calculator help me with that one. And I get $42,436. All right, and then at the end of the third year, we would take that $42,436 and multiply it by 1.03. And we would get $43,709 and some change. $43,709 and 8 cents. All right, so after a while, suppose we're thinking, this is getting a little tedious. What if I want to know how much money I'm going to have at the end of 10 years? All right, so could we come up with a formula so I don't have to calculate the 4th, 5th, 6th, 7th, 8th, 9th year to get to the 10th year? Okay, so look at the pattern of what happens. After our first year, we took 40,000 times 1.03. Okay, and then we took that, which was this 41,200 here. That was really taking our 40,000 times 1.03 from the last line and multiplying it by another 1.03. Right, and then after the third year, we took that answer okay, that's the 42,436, and then we multiplied it by another 1.03. Okay, so each year we're just multiplying by another 1.03. So after the first year, our salary had been calculated by 40,000 times 1.03 to the first power. The second year was calculated by 40,000 times 1.03 squared. And the third year, we had 3 of those. All right, and you can double check that these calculations in blue actually give us the same salaries as we got multiplying it step by step. And so we would guess that after our 10th year, we would take $40,000 and we would multiply it by a 3% increase 10 times. Okay, and that would give us a salary Oops. And I get 53,000 and a bunch of numbers. Let's see, 53,756. I'm going to have to round those pennies off, about 66 cents. Okay, so that would be your salary with a 3% raise every year through the 10th year. Okay, so we would say that we have a salary function. We could do this for 10 years, 20 years, however many years you wanted to do it. Okay, so we would say that our salary function, we could say after X years, would be 40,000 times 1.03 to the X. All right. And that is what an exponential function looks like. Instead of having the X down at the bottom, we've been doing polynomials forever where it was like X to the 5th. But now we have the X up in the exponent. Okay, so that's exactly what an exponential function is. An exponential function is one of the form f of x equals ab to the x. All right, so I'm just going to kind of use our salary function as an example. 40,000 times 1.03 to the x. All right, so we have our A is 40,000 and our B is 1.03. All right, so that A is non-zero and is called the initial value. And that's because that's the number that you get when you start. Okay, so if you have, if you're talking about when you first start your job, that's when you've had 0 raises. That would be 40,000 times 1.03 to the 0, or anything to the 0 is 1. So that would just give you your initial starting salary. Okay, so that's why we call that A the initial value, because anytime you plug in x equals 0, you're going to get this exponential part to be equal to 1. Okay, so A is whatever you're starting with, however many dollars or people or bacteria or whatever it is that you're studying with your exponential function. All right, B is a positive number and is not equal to 1. If B was equal to 1, this function would be very boring. If you had the $40,000 and you were having 1 to the x, okay, this is not a very good offer from your boss. This means that they're, no matter what we plug in here, 2 or 3 or 4 or 5, they're just going to keep multiplying your salary by 1. Okay, that's not really an exponential function. It's not really moving anywhere with that number B. Okay. That would technically be a linear function that stayed at $40,000 for the rest of your life. That's not a really good prospect. All right. And then that B tells us a little bit about what's happening. If B is a number bigger than 1, okay, which was our case, we had 1.03 to the x, and our B was slightly bigger than 1, that indicates growth because we were increasing by 3%. Likewise, if we had decided to multiply 40,000, hopefully you don't ever get a job that does this, if it were decreasing it by 3%, it would be multiplying it by 0.97 instead of 1.03. It would sort of like subtract the 3% rather than adding the 3%. All right, and that would calculate you a salary that was decreasing or decaying over time. All right. So, and there are things that decay exponentially, like radioactive elements have half-lives. They tend to decay over time. And sometimes depreciation of cars or houses or valuables, those can decay exponentially. Hopefully, though, our salaries don't ever decay exponentially. That would be not good. All right. Okay, so this is just our introduction to exponential functions. And when we are in class together, we'll plot some points and figure out what the graphs of these things look like.